Hello friends, my name is Amasu. Today we shall discuss about topic the basics of cloud native applications. Friend, today's topic is very interesting, especially if you have interest in cloud computing and you want to learn about it. So let's start, friend. Friend, first of all, we have to understand that what is cloud actually. Whenever we talk about cloud, basically we are referring to remote servers on which different services like application, software, the infrastructure, platform, database, storage, etc. So different types of services are available remotely, and we as a customer are using those services through the internet, through remote servers. So this is basically the main concept of cloud. Rather than deploying all the applications in on premises, we use the remote servers to access those applications. Now, what is cloud native application? Basically, friend, cloud native means that those applications which are using the cloud platform to access the applications. Okay, so this is basically the concept of cloud native. That application, those applications which are based on the services on the platform of the remote servers. Like for example, let me give you an example. Like for example, Netflix is a prime example of cloud native application. It utilizes microservices architecture to break down its system into small independent services. Netflix relies heavily on cloud resources for scalability and employs and took tools like Kubernetes for container orchestration. Netflix is basically using cloud services. Also, another example of Spotify is a very popular music streaming service, embraces a microservices architecture. It uses containerization for deploying and managing services across different environments. Continuous integration and continuous deployment pipeline enable frequent updates and features releases. Basically, friend, cloud native applications are a type of software that is designed and built to leverage the capabilities of cloud computing infrastructure. These applications are developed with a set of principles and practices that aim to take full advantage of the dynamic, scalable, and distributed nature of the cloud platforms. Okay, now we shall talk about in detail about these cloud native applications. First, we will talk about microservice architecture. Friend, cloud native applications often adopt a microservice architecture. Microservice architecture is basically an architecture based in cloud computing where the application is broken down into small independent deployable services. Each service is responsible for a specific business capability and communicate with other through well-defined APIs. Okay, so this is basically the concept of microservices. Microservices are basically simply an API, application programming interfaces, just to access the application, just to access the database and services. Then containers are lightweight, portable, and consistent environments that package an application and its dependencies. Technologies like Docker have become essential in the cloud native ecosystem, providing a way to encapsulate and deploy application consistently across different environments. Containers nowadays very popular. Simply, a friend, think of this container. Just see the word container. That means it is a container. It is a thing which contains the application, the environment, dependencies. So basically, just think of this as a box in which all the things have been packed. And then orchestration. Container or orchestration tools such as Kubernetes are used to automate the deployment, scaling, and management of containerized applications. These tools help ensure high availability, fault tolerance, and efficient resource utilization. Basically, friend, if you have a concept of container, that what is container? So for the deployment of container, we use the concept of orchestration. Then DevOps practices. DevOps, basically there are two words, development and operations. So DevOps, development, operations become like they are synced with each other. So cloud native development embraces DevOps principles, fostering collaboration between development and operation team. Continuous integration CI and continuous deployment CD pipelines are employed to automate testing. deployment and monitoring processes, enabling faster and more reliable software delivery here as well. Then infrastructure as code, IAC. Friend, this is a new concept here, that infrastructure as a code involves managing and provisioning infrastructure through machine readable script files. Tools like Terraform and Ansible are used to define and automate the deployment of infrastructure components, ensuring consistency and repeatability. Then friend, next is the resilience and fault tolerance. Friend, cloud native applications are resilient to the failures. Resilient means that they try their level best to avoid the failures, because we know, friend, already these applications hosted on remotely. So if there is any issue occur, so obviously it will become very much difficult to recover them. And so cloud native applications are designed to be resilient to failures. This involves or means that strategies like redundancy, load balancing, and the ability to gracefully handle and recover from errors. Redundancy means that we will have a copy of the applications or more than one place. Load balancing means that if there is any load on the server, we have a mechanism to shift that load to some other server. Okay. And if there are any errors, so we have a mechanism to recover from the errors. Distributed architectures and data storage systems contribute to improved fault tolerance here as well. Then scalability. Scalability means that cloud native applications can easily scale horizontally by adding more instances of services to meet changing demand. Okay. This scalability is achieved through features like auto scaling, which dynamically adjust the number of instances based on workload. Basically, friend, whenever we have some event, for example, at which the sale will increase, so we have a mechanism in the cloud computing that it will automatically increase the instances to handle the request of customers, so that customer, it will be transparent for the customer to see any changes or any load. Then dynamic resource allocations means cloud native applications take advantage of dynamic allocation of resources in the cloud. This include elastic scaling of compute resources, storage, and other services based on demand, optimizing cost and performance here as well. Logging and monitoring. Robust logging and monitoring are integral to cloud native applications. Tools like Prometheus, Grafana, and ELK stack help track application performance, detect issues, and provide insights into system behavior as well. Then security. Security is a top priority for cloud native applications. Practices like secure coding, identity management, encryption, and regular security audits are essential to protect applications and data in the cloud.